All right, here's note 7.6 for my honors algebra 2 class. Going to kind of go fast through this since we covered most of this stuff inside of class. First two examples are going to be rewriting logarithms in exponential form. Next two are going to be evaluating logarithms. Example 5 will be finding inverses, and examples 6 and 7 are graphing. So we went over what a definition of a logarithm is. Basically, what we learned from this is the spiral method. So this equation right here is the same thing as this equation over here. B to the x power is equal to y. So b to the x power is equal to y. That's how you can memorize that. So first couple of problems are going to be rewriting equations. So you're going to rewrite this in exponential form. So you use a definition of logarithms to write it. And like I said, you're going to take the base, which is this 3. So it's going to be 3 to the 4th power equals 81. We called that the spiral method. So it's not really a technical name for it, but if you do 3 to the 4th power equals 81, whoops, that's a 1. And if you think about that, 3 to the 4th power is an 81. So this equation in logarithm form is the same thing as this equation in exponential form, right? So these were think pair shares. I'm just going to go through these kind of faster. So spiral again. So it'll be 2 to the 5th power equals 32. And double check that. Is 2 to the 5th power equal to 32? Yes, it is. Go around here, spiral around. To rewrite this one says 5 to the 0 power is equal to 1. So that's true. And 1/2 to the negative 1 to the negative 1st power is equal to a 2, because negative exponent property makes it the reciprocal, right? So that was just the first few problems. You're just going to be doing this quote unquote spiral method to rewrite expressions, so that, or equations. So this is a statement equation. You're just rewriting it as another equation. So now this is slightly different because I didn't tell you what this is equal to. So to evaluate a logarithm, so I want to know what this entire thing is equal to. So log base 3 of 81 is equal to what? Now what you should be thinking in your head, so I'll do a little thought bubble here, is 3 to what power is equal to 81? Reason being is because if you do the spiral, then you come around here. This is the part that you don't know. So once you figure this out, you figured that out. All right, so let's figure this out. So 3 to what power is 81? So 3 times 3 is 9. 3 times another 3 is another 9, and 9 times 9 is 81. So that's going to be 3 to the 4th power. And that's how you evaluate. Moving on, let's do a few more examples like these. So this one gets smaller. So what you should be thinking is 9 to what power equals a 3? Now I know that there's fractional powers, and I know the square root of 9 is equal to a 3, and the square root of 9, same thing as a 1/2 power. So it must be 1/2. This one, so you get 1/2 to the what power, because I don't know what it's equal to, equals 8. Now notice you got a fraction that turns into a whole number. So, but I know 2 to the 3rd power is an 8. But that's not 2, it's 1/2. So how do we flip things over in math? We use negative exponents, because 1/2 to the negative 1 will be a 2. But then you got to do it to the negative 3rd power, because that will turn into an 8. So negative 3. Since you don't know decimals, so that's going to be 4 over 100. So it's best to turn decimals into actual fractions, which is 1 over 25. So 5 to what power is 1 over 25? First off, it has to be a negative, and then must be a negative 2, because 5 to the negative 2. Negative flips it over to 1 over 5, and then times another 1 over 5 is 1 over 25. All right, so like I said, I'm going kind of fast through this. Let's see. Okay. Special logarithms. There are two special logarithms. You need to know their names, the common and natural logarithms, base 10 and base e. If you have log base 10, this comes up so often that we call it the common logarithm, that if you just see log of x, then it's implied there's a 10 there. Kind of like if you have a square root with just a square root symbol, you don't really have a 2 on the top of it. You just it's implied. Same thing here. We went over the natural number, e, Euler's number. So Instead of writing log base e, this comes up so often that we just write ln. Sometimes you'll catch me putting a capital L. It's actually supposed to be lowercase, but I do a capital one sometimes. So log base e is the same thing as ln of x. So if that throws you off when you see an ln, you can always rewrite it as a log base e. All right. I wanted to show you guys part of the reason why we canceled this, but we did that in class, so I don't think we really need to do that in this part. Finding inverses, just a little recap, switch your x and your y, then solve for your y. Make sure that your logarithm is isolated before you do anything. Cancel the logarithm by writing in exponential form, so basically do the spiral. All right, so here we go. First off, switch your x and your y. So this will be x equals log base 3 of y. Now we need to make sure that our logarithm expression is isolated, meaning there's nothing outside of it. So for a logarithm to be an entire expression, you have to have the log, you have to have the base, and you have to have something that the log is being done to. So it's being done to the y. Now there's nothing else on the outside like a little +1 or divided by something. So this is already isolated. So once you have it isolated, the entire logarithm, then you do the spiral around. So it'll be 3 to the x power is equal to y. So we're going to spiral around because that's the definition of logarithm. 3 to the x power equals y. Clean this up a little bit, and the inverse will be y inverse is equal to 3 to the x power y prime. Okay, next one, ln. If you remember ln, if you rewrite this, you don't have to rewrite it like this. You can just kind of keep this in your head. Or actually, let's do the x first. Switch your x and your y. ln of y plus 1. Now, notice the grouping symbols. The grouping symbols mean that this is ln to this entire thing. So this is actually one big logarithm. Now, ln means you have a base e. So you actually have like a little e down here. If you think of this as a log, that's a log base e. So what you're going to do is spiral. So e to the x equals that. So e to the x power equals y plus 1. Now your y is not isolated, so you have to subtract 1 on both sides. So basically you get y equals e to the x power minus 1. And that's y prime. I forgot if I told you guys to put a -1 or a prime. We'll say y inverse. Last one. So first off, this little 5 over here is actually not part of your logarithm. It says log base 4 of x, so you're going to do that, and then you add 5 later on. So if you're solving, you need to get rid of that 5 first. Whoops. You need to switch x and y first. Sorry about that. So x equals log base 4 of y plus 5. So you're going to subtract 5. So x minus 5 equals log base 4 of y. Now we can spiral now that we have that by itself. So spiral around here, here. So 4 to the x minus 5 power equals y. So y inverse is equal to 4x negative 5, x minus 5. All right. Reason why we're doing that is because we're going to get into graphing. And there's the bell. Boop. All right. So graphing logarithms. Now, you'll notice that we have h and k still. This keeps coming up. These are our shifts. H is our horizontal shifts. K is our vertical shifts. So inside opposite for h, and k just goes up and down. Now, first off, just like we did with exponentials, make sure you count for your shift. You got to make 2 tables if there is a shift, a non-shifted table and a shifted table. Optional, but I would say that you probably should do this. Rewrite it as an exponential. Since we already know how to graph those, that'll make it easier on you. Make sure you graph at least 3 points, and like always, label your asymptote. Okay, this just shows you that you can create the general form of exponential from a logarithm. So let's do this one. So first off, we have a shift. Now notice this -1. It's next to your x, but it's actually not part of your x. So the whole inside opposite doesn't count here because this is log base 1/3 of x, and then you're subtracting 1 later on. If this was in parentheses, then it would be your h. But as it is right now, since it's not in there with the x, it's part of your k. So that's your vertical shift. right? So basically, we're going to make two tables, x, y, and we're going to make a shifted table over here, x, y, and then you're going to subtract one from your y values because it's getting shifted down. Now, I'm going to rewrite this without the shift, so y equals log base 1/3 of x. Right? So I rewrote that. Now I rewrote that. Now we're going to take the base, spiral it around so we can write it as an exponential. So 1/3 to the y power equals x. So 1/3 to the y power is equal to x. Um, Now, if you notice, this looks very much like an exponential, only the x and y values are switched around. So this is going to be a little bit different because now your inputs are actually going to be your y values. That way you can evaluate it over here and get an x value back out. So since we took the shift off, we're going to put 1, 0, -1. But it's not going to be on the x side, it's going to be on the y side. Reason being is because we're plugging in y values, getting out x values, because that's the way our equation works. We got to plug in this y value, evaluate this side, and that's what our x is going to be equal to. So it's kind of like your exponentials in reverse, which makes sense because logarithms are exponentials inverses. So there you go. So just evaluate this. If you plug a 1 in for the y, so 1/3 to the y power is 1/3. Sorry, 1/3 to the first power is 1/3. So x is equal to 1/3. Right? 1/3 to the 0 power is 1. So x is going to be a 1. 1/3 to the -1 makes it flip over, so it'll be 3. So x is going to be a 3. There you go. Now, this table looks a lot like how the exponentials did, like I said, but it's in reverse. Usually the 1, 0, -1's over here, and then these numbers look similar to the numbers that we usually got over here. But still, we got a shift, so it's going to be 1/3, 1, and a 3. We're going to subtract 1 from our y value, so that's going to be a 0, a -1, and a -2. All right, so now we're going to graph this thing. So dual page. Now, since exponentials had asymptotes that were horizontal asymptotes, turns out logarithms have horizontals that are vertical. It's because of the whole inverse thing. It gets reflected over the xy axis. So your asymptote lives on the y-axis. That's the non-shifted one. Now it only moves when you get a shift. Now the shift right now is -1. So if I were to move this green asymptote down 1, that doesn't change anything because it goes up and down forever. So it turns out that -1 shift doesn't really affect the asymptote. The asymptote is still on x equals 0. So asymptote is at x equals 0. You have to um, you got to label your asymptote, so that's it. Okay, now we're going to plot the points. So 1/3, comma 0, 1, -1, and 3, -2. So let's go out here. 1, 2, 3. Okay, so 1/3 is about 1/2. 1/3 is at 0, so it's about right there. 1, -1 is about right here, and then 3, -2 is about right here. Now remember, to create this, you have to start close to the asymptote, and then should still look like a ramp, and then it goes out that way. And that is your logarithm graph. Now if you tilt your head, yeah, go ahead, tilt your head, and you will see that it is a ramp shape. It looks kind of like exponential, okay? So let's try this one, and then we're done. So once again, we got a shift. This is my H, this is my K, right? So go to make your two tables, x, y, over here, x, y, but you're going to be subtracting 3 and adding 4 for the shift. You're going to rewrite this as y equals log base 2 of x. You don't need anything else. And then spiral around, you'll get 2 to the y power is equal to x. We're going to plug in a 1, a 0, and a -1 for your y. Okay, evaluate. So 2 to the first power is 2. 2 to the 0 power is 1. 2 to the -1 is 1/2. Now we're going to subtract 3 from those x values. So 2 minus 3 is a -1. 1 minus 3 is a -2. 1/2 minus 3 is -2.5. Okay, add 4 to this. That'll be a 5, a 4, and a 3. let's see, 4, 5, 4. Okay, so yeah, that looks good. So it looks like our x values are all negative. So I'm going to make this side bigger. Y values are all positive. Positive. There you go. And let's figure out where the asymptote is. So the asymptote lives on the y-axis for logarithms. Now we got to shift it. So your h is 3, so you're going to move it to the left 3. So inside opposite, so it's going to go 1, 2, 3. And then it goes up 4, but remember the up and down shift doesn't really do anything, only the side to side. So 1, 2, 3, your asymptote is there. All right, so it goes up to 5. 1, 2, 3, 4, 5. Okay, so negative 1, 5. It's way over here. Then we got a negative 2, 4. It's right there. And negative 2.5 is at 1, 2, 3. Okay, so it looks like it's getting closer to the asymptote that way. So start close to the asymptote and then go away on the dots. And it should be a ramp shape. That way. And there you go. That is how you do that. And that's the end of the notes, so you should be able to figure out how to do those from here. Okay, bye-bye.